Okay, so let's get started. So my name is Manu Gosain. I'm from Northeastern University. The hat I want to wear here today is as part of the Power Project Office. Power was a program called Platforms for Advanced Wireless Research, recently announced by the NSF, well, in April 2017 as part of the Advanced Wireless $400 million investment. Our goal is to fund 4 city-scale advanced wireless research platforms, and sparing you some of the details of the program. We fast forward to April 2018 when we funded one of the platforms called Cosmos, which is actually based in New York, with the main team members responsible for developing and deploying that testbed being Rutgers University, New York University, Columbia University, and the city of New York. And lo and behold, their main wireless research focus is millimeter wave systems, hence our interest in this community. And as it is a deployment, a large city-scale deployment envisioned in millimeter waves, we really wanted to get input and feedback from experts here in the room, as well as on the panel, who I'll introduce in a second, about what are the different ways and what are, first of all, what are the needs of this community when it comes to systems and testbeds, where this community is in the technical roadmap of developing systems, as well as how best could we accelerate some of that research and produce systems that can be of use to the community. So that'll sort of be the theme, and we'd love to hear. It's again, an open forum. Discussion questions are best. We're not going to be presenting much slides, but we did put forth some questions. With that, I'll pass on the mic to the other panelists here. So Kira, do you want to introduce?
Sure. I'm Kira. I'm with National Instruments. I'm part of our business development and lead user team, and I work with lots of researchers and companies in setting up testbeds and helping to understand what products would make sense for us to be developing to support testbeds.
Hi, I'm Greg Lacaille. I'm a PhD student at UC-Berkeley, and I'm leading our effort to build a testbed that's a 128 element massive MIMO implementation at 75 gig. So we've been kind of working on that for the past couple of years, and all the hardware is coming together, and we're entering the final stages of integration now.
I'm Han Liu with Catholic University. I'm a faculty member there, and my research is mainly on the millimeter wave networking, on massive MIMO, and some other related issues.
Okay, so when we were sort of tasked with running this this panel or this discussion breakout, some of the questions that we put forth, that we've put up here, the first thing is, again, how does a testbed benefit this this community? And again, we understand there are multiple stakeholders, both from academia as well as industry, who participate here, and essentially, you know, what stage of that development roadmap do we have? We know industry is much further ahead. We heard earlier today about trials that have been done by Verizon and AT&T with millimeter waves, and you know, we want to get a sense of what that gap between industry and academia might be, and how best can testbeds that might be developed, or this input that can be then relayed back to the National Science Foundation with respect to what is missing in this community, and how do we best accelerate some gaps. So we have some academic folks here. Maybe I start with Greg with respect to where you are and where you see industries and some of the gaps, if you may address those.
Sure, yeah. So as far as what we're doing at Berkeley, we've kind of, you know, taking 2 fronts. We're you know, at the end of the day, we do a lot of custom ASIC design, and we kind of want to move down that road so that we can demonstrate, you know, energy efficiency and form factor and things like that. But, you know, building an ASIC is kind of an enormous undertaking. So we're also kind of exploring off-the-shelf solutions that, you know, might burn kilowatts of power and, you know, be the size of a refrigerator, but they'll work, and we can kind of prove stuff out that way. So I think kind of both of those roads are important for, you know, what we're doing.
Yeah, and maybe I can add a little bit. So, and right now my research is mainly focused on higher layer protocols like media access control, multipass access, and you know, and mobile device association, so which base station associated to, you know, and whether or not to go multi-hub or etc. Right? So mainly our research right now is the tool we are using is simulation and analysis. So I think that the test bed is really, really important. So I still remember, several years ago, everybody was working on this wireless line, right? So we work on these ad hoc networks. So we work on, and the different wireless line techniques, especially for the higher layer. There are different routing protocols, different media access control protocols, power control, or different tricks to form networks. So, but for the millimeter, so there were a lot of experiments because wireless LAN was available at that time. Then there were multiple test beds were built, like Rutgers, they had this Orbis, or then there's a Genie project, But right now it's lack of test bed for the millimeter wave, right? So even now, and people are trying to build. So, but still not there yet. So from component point of view, you may get here or there, right? So, but for the more systematic research or the large test bed, is still not there. So, but I think that's the key, critical. And also, a lot of equipment are very expensive. So like NI equipment, so we have to spend a lot of money on that. So, yeah.
Kira, do you want to highlight where industry is based on your interactions with them on millimeter wave systems, etc.?
Sure. That is definitely feedback we get a lot is we want it better, cheaper, faster. But there are definitely constraints within industry of how do you actually make a product and make it something that can be usable and scalable. So that's really where we are is trying to make it scalable and make experiments that can be repeated.
Okay, perfect. So I guess just to, let's start again at the base of what the fundamental problem is. I think I want to sort of jump off a comment that was made earlier in the morning. I think Akbar made that point where the radio designers and the network designers aren't really, speaking to each other and aren't really aware of each other's constraints and issues. We obviously see testbeds as one place which sort of is very democratic, which allows different players to come in and actually integrate solutions end to end to really understand and implement, application services or actually play at each layer. So what sort of one of the things I guess we want to understand here, and we want to reflect that back to the wider audience when we do reports out, is where do we actually see the benefits of testbeds for millimeter waves? I think clearly there's a pain point where people have put their head down and are really moving aggressively. And we also heard, I think it was quite openly stated, at least from the Qualcomm perspective, that if you don't try to get into the modem game, that's just the barriers of entry are too high. So where can we actually play? And that sort of gets into the further away you move from silica, I think that's when things start to get a little bit more open. Are we there yet in terms of addressing fundamental research questions in the millimeter space that would actually call for development of testbeds? Is there more? And that sort of, I'm jumping a little bit ahead, and I apologize if there are any international members in the audience. I'm just using some standard NSF terms up here. So this is switching gears with respect to, first of all, what is the need? And if there is a need, how could that be fulfilled with respect to the current instruments we have as part of our different agencies that we can rely on for funding such testbeds? So, again, pose that question where are we at a stage where the technology or the research is mature enough for community size, large-scale testbeds, or do we still need fundamental challenges or fundamental questions answered that might be done at an institution or at a much smaller scale?
Yeah, I guess one thing that I would kind of chime in on is that I think, building these kind of large-scale testbeds and building them in kind of a flexible, reconfigurable way actually really helps us inform what we need to do, right? I think once you get to the point where you're going to build something that's actually commercializable, there's going to have to be a lot of analog mixed signal design. You're going to be doing hybrid beamforming, things like that, and it's going to be a tightly packaged kind of system. But to get to the point that you are going to want to actually be confident in what that system looks like and know that you're building the right architecture, you want to have more than just kind of pairing, some building block characterization with some MATLAB sims. So, that if you talk about building, fully digital arrays with kind of FPGA implementations that are highly programmable, yes, they might, burn a kilowatt, but you can actually emulate the analog, say, in those designs and show that, like, okay, I threw away, these many bits of resolution and I left these things partially connected, and I can kind of almost match these systems. So I think people building these flexible test beds is really good, and just finding a way that we can make it cost effective for them so that they can build something and test out a lot of different scenarios on a flexible platform will help move things forward.
I guess along those lines, I would sort of change the question a little bit and say that I don't think that they're necessarily mutually exclusive, but they should build off of each other. And how do we make sure that we build both types of test beds so that they can, so that there's no barrier between them? It's not necessarily that you have one small CRI at your university and that means that you can't make use of a larger city scale test bed. So how do we kind of flip the question and make sure that we're utilizing our resources as best as possible, which I think is along the same lines as what you were saying.
Yeah, I also think so, and on the other hand, right, and typically if you have these smaller test beds, so you can do some prototyping by yourself, with more like an in-house, right? So then, because most of a large community test bed is far away, even we have a good management platform there, like Utah has or Rutgers has, right? So, but it's still far away, and you have to schedule it, and if you can have some internal sandbox type of thing, at least you can do some experiments, and also I found, some students, they are more used to see something before they can do it, right? So if you have this remote test bed,
right. So there's an inherent trade-off there. At least, the good thing there is that this is the area where everybody wants to work. But because we are at such an early stage, things are obviously a little bit more cost prohibitive for sandboxes at each of your home institutions, which I'm sure as academics you're aware of. So that's sort of the, and that's where a shared test bed sort of lets you defray some of those, costs, because you sort of optimize the usage of those resources, et cetera. So that's where I guess the scale question that I was trying to pose, and if this is seeming a little bit more amorphous of, test beds, I'm happy to sort of just go over, we don't have the Cosmos folks in the room, but I'd be happy to go over what the thought process for the millimeter wave test bed that this team has envisioned, and it might help sort of stimulate thoughts around, and we have a lot of open questions that we are hoping to answer, if that helps.
So I'm Stefan. I'm from Freefall. We're a startup company out of the University of Arizona down in Tucson. So Tucson is a very kind of close-knit community. So you do have stuff like there's a hacker space where people can join and go and use tools and stuff there. So community level, something like a scalable test bed would be good. Our company, we develop a lot of stuff in-house. Mainly it's been simulations, and now as we move towards this 5G, we're finding, well, we have to go out and get this equipment that can go to these frequencies. And we know that the frequencies are going to go higher and higher. So with that, we also want to have equipment or a test bed that would be scalable for that, so we're not having to rebuild from scratch constantly. So that's just kind of my initial reaction on that.
Yeah, so eventually the idea is that within the Cosmos testbed in New York City, you'll have access to 2 millimeter wave technology within a city scale testbed. Is that something that you would then, I guess, what would barriers of entry to using something like that be for you and for your company?
I imagine at that point just accessibility to it, being able to access it at a reasonable cost. So, especially if it's a well-defined test bed, then we can build our stuff to interface with it and then just go utilize it.
For me, 100 gigahertz is the low frequency end. So, talking about community scale test beds above 100 gigahertz is sort of it's kind of like talking about opening an ice cream shop on the moon. It's a little bit ahead of its time. But I don't know, is Cosmos got anything at frequencies above 95? Well, okay, then give me a call when you're ready. Because we can make measurements as high as you want.
It's echoing Dan's comment is, when this was billed as a millimeter wave session, it's really a solely 5G millimeter wave session.
No.
It's not solely 5G.
No.
It's solely below 90 gigahertz.
It's open. I think we're trying to obviously understand what the requirements are.
Okay.
And how they might change. So yes, please.
Well, let me comment, give a preview to my presentation, is a key issue above 95 gigahertz is coexistence with passive satellites. And a key issue of that is measuring antenna characteristics. And there's no convenient common source for measuring antenna characteristics. NIST may be about to open a better test bed, but maybe they are, maybe they're not. So an important test bed for those of us who are interested in above 9,500 gigahertz is verifying the performance of antennas, particularly at side lobe levels. Side lobes are very critical for sharing, and there's no open source to measure side lobe levels, and that would be a common resource for the technical community that, whether it's NIST or NSF supporting it, would be very useful.
Actually, so maybe I can kind of just ask a question to the audience then in terms of, I think when we talk about these test beds, it can be in kind of a couple domains as far as what it's actually being used for. So kind of the stuff that I've been interested in that kind of Hydra is pursuing at Berkeley is really kind of this co-design of circuits and systems and kind of end-to-end functionality, right? So we really want to explore all the way from network level to PHY, how do these things actually kind of play together? And so in that aspect, I don't think there's like a huge difference between 75 gig and 140 gig in that, it's mainly digital. You have a direct conversion front end, and it changes the propagation characteristics slightly. So that's, I think, one aspect of the test bed. And if changing the front ends and moving to over 100 gig is something that adds a lot of interest to the community, it's something we should be talking about. And then also, I guess what I'm kind of hearing is that there's also still a lot of purely PHY research that people are interested in. And so how can we maybe design these platforms to kind of satisfy both needs?
And it doesn't need to be one size fits all sort of an approach. So what sort, and that's the point here is, again, not to come to any consensus, but understand the landscape better. So what we have again today with, if you call that 5G, would be 28, 39, maybe 60, which is unlicensed. And then, you could compartmentalize that as short and medium term, because that's probably where the industry players might be more interested. And that might be a space that's probably ready for some of these system level integration issues, which some of these test beds might be amenable for. For the frequencies that you're talking about, going up above 100, et cetera, there are fundamental research questions that need to be answered. And that's where, you need calibration instruments. You're looking at it from a different perspective. So I think much earlier, of course, and that's where we want to put that on. So when we do present this, at least to the when we report it out, we obviously want to break it into if the group here thinks that's a fair distinction to make between a short and medium term versus going forward.
Even at 5G, while the bands that you've mentioned are the ones officially designated for 5G as of today, there certainly is discussion in the cellular community of 70, 80 gigahertz. So if you're in the R&D business, while no decisions have been made on 70, 80 gigahertz, and there are some awkward issues about present users versus 5G, but am I the only one who reads publications that say there's discussion of 70, 80 gigahertz as possible? Right, so, if you're building test beds other than for what's about to go in production next week, and I would hope that NSF-supported things would be focused not only on what's about to go in production next week, because it's supposed to be fielded by 2020. The FCC is obsessed to win the race to, FCC and CTIA are obsessed with winning the race to 5G, whatever that means. There certainly is discussion of 70, 80 gigahertz, so there should be some capability, even in the 5G community, of not just focusing on today's official bands.
Yeah, so I think I'm going to interject a couple of things. So we have, it's a little bit of a sparse audience here. So this is also going to seed the questions in the discussion tomorrow in panel 2, because testbed development is an important topic, and I'm sure that people in the other breakouts are interested in that as well. So I'm going to reframe it. I would like, Manu, you to give a little more, add more to the power. My understanding of power is that, it's going to be more of an infrastructure so that we can explore 5G and beyond. Any kind of emerging technologies so that you can have a city-scale test beds to explore them. And in terms of the questions raised by Dan, there's a fine line between what's stable and ready for that city-scale test bed and very nascent and really, has to be nurtured in a lab. So as it gets forward, maybe there can be partnerships formed to move it up there. So it's going to be a combination. But going back to Greg's comment, end-to-end simulation is of interest. And so right now, there are very few platforms available. And in fact, NI is a monopoly. And so we want to break it. With all due respect, we want, so it shouldn't be just that. I think, so in my lab, before I was at NSF, we were building a test bed where we did the whole front end lens antenna arrays and the RF and the back end FPGAs. And it's a lot of work, but you can do it. And I think some of it is done at UC-Berkeley as well. And so there are alternative versions too. You can make it more compatible with MATLAB in addition to LabVIEW. And so the question here is, what would be useful to people? Some may be interested in just the antennas, and before they can get to power platforms, they may be able to partner with some other researchers, say Berkeley or even in my lab, where they could be, those systems could be put as part of an end-to-end system, or some other players who may be using NI platforms. Right. And, or, can the community, if say Berkeley and other people are developing FPGA-based protocols, those take time, can they be done in a modular fashion so that they can be shared with the wider community? Some of it may be developed in power. So we want to look at all of those aspects combined together. And so with that, maybe Greg, you can say a little bit more about what are you guys doing? Is it FPGA based? Are you interested in, do you think it's in a place where you can share it with other people, the designs, and what could be done there? Maybe Kara can say something about next level, maybe the USRPs. I know that maybe they're at a better price point where you are playing with more of the higher level functionality. And then Manu can say something about power as well.
Yep, that's great.
Sure. I think kind of at Berkeley for like this Hydra project, we've kind of built it up to a point where we have a platform that's kind of tied to our architecture, but the hardware that we've built can be kind of adapted. So we're going to be taking a couple fronts where right now it's an uplink only, so it's just kind of the handset talking to the base station, and that's been kind of easy for us to make modular and kind of build up one step at a time. So there's kind of a front to kind of keep going on that and explore like what we can do in the uplink architecture, and there's a front to kind of add downlink functionality. So when it comes to like interfacing with other people and collaborating, I think actually, very soon we would be on the front where we're kind of able to interface on the uplink side, and we would love feedback from people on, what things they would like to explore on that side, what kind of Mac level and network problems they could kind of use our platform to explore. I realize when it comes to doing network level stuff, it's kind of hard if you only have one direction of the communication. So I think that getting the other direction is kind of a priority for us and something that's coming down the road. And hopefully once that's up, then we can definitely plug and play with people more. But we definitely want to have collaboration on both what should be in the stack above us and making our platform at the PHY level available so other people can also kind of explore their own PHY level algorithm of choice.
Just before you pass on, if you could just touch on some of the, and I'll do that for the Cosmos one. But what are sort of the biggest barriers that you see in your development? What sort of
packaging? Millimeter wave packaging is a pain. It took us a long time to get to a front end that we could kind of reliably assemble with high yield to build up a large number of antennas. I think we're there to that at this point. Fingers crossed. We do have kind of 64 antennas kind of up and running now, but it was a pain to get there because you're kind of in this weird space of not low volume, but certainly not high volume. There are not a lot of people that want to work with you in that space. So that was I think that's kind of our biggest barrier to entry. And then cost I think is a barrier to entry for everybody. I went back and kind of crunched the numbers, and obviously we had to respin boards in our design and stuff like that. But I think now knowing the full design, if you wanted to buy everything from scratch with no donations or anything, building a full Hydra system would cost you around $300,000. Right, and that's 128 base station antennas and 16 handsets. So it's a lot of functionality for that, but it's still, for a university, a very significant cost.
Mm-hmm. Okay, so let me ask a follow-up on that. So one, the barrier to, the packaging, was it, a little bit more, did you have to work with a third party to manufacture it? You had to design yourself? And two, out of 300K, how much of it is your digital backend and how much of it is the front end phase array and RF?
On the packaging front, I think, the embarrassing thing is that it gets to the point that the key to success is knowing the right technician at this company to call to make sure he's the one actually running the wire bonder for you, right? It's kind of silly that you have to get to that point because you're paying them for a service and they should be kind of doing this to some specification. But at these very low volumes, if you're talking about I'm doing 100 elements and I need a yield of better than 90%, that's kind of the space you're at. So I can share the email of our contact at that Wirebond house, but probably if everybody decides they want to do this, they're going to have to find their own guy that is the right person to be emailing. So I think that's, for Berkeley, we've kind of solved that barrier, but I don't know that I have an open source solution for everybody in that space. For the cost, I think it breaks down actually pretty, for kind of the fully digital direct conversion architecture that we did, it broke down pretty cleanly. It's about 25% FPGAs, about 25% data converters, 25% 75 gig front ends, and 25% packaging cables and odds and ends and stuff like that.
I think the USRPs. I mean, are you where is NI in its ecospace of offerings? I know that you guys have the high-end PXI or whatever, and then you are also going to do some USRP level production, because some of the things may be interested to people who want to do PHY layer, other things who are maybe on PHY is fixed and they want to play with some of the networking layer USRP kind of architectures maybe relevance to, so you can say something about that. And also you have partners in your system. So going to Greg, you know, even UC-Berkeley's partners, I know you don't want to give the number away, but I think we shouldn't leave it out, because there may be, it's not just one person, one company, there are multiple companies, and perhaps we can do something here. So it's not out of the option. And then maybe NI has partners who may be willing to work with the community to develop some of the stuff. And you know, maybe we can even help in some of the painstaking work that those people have to do before they do their specialized work. So I want to think us out of the box.
Sure. So I think there were a couple of questions in there. So I'll start with the topic of USRPs. So I typically, in a millimeter wave type of conversation, would leave those out, only because they're 0 to 6. And pretty squarely in the 0 to 6 range. They are definitely our lower end offering, but also FPGA enabled for that 5-layer prototyping. The nice thing about anything in 0 to 6, if you have a front end that would be down converting that low, then you could plug them in front of a USRP and automatically get that scalable architecture there that you're looking for, which I think is the direction we might end up going in one of the power programs. To answer your question about partners and expandability, I think the demo right out front is a great example of, similar to the USRP, but even on the PXI platform, being able to take the same physical layer, the same, for that example, it's channel sounding, and putting and stepping from the 60 gigahertz channel sounding and prototyping and measurements, and then putting, I believe it's 140 gigahertz front end on it that's out there right now that Ted's group is doing. And our goal with our architectures is to make that an option. So whatever front end you want to use, whether it's NI or not, if you can put it in front of our hardware, and then whatever software you've written can then be scaled to that frequency based on that hardware. So I think that's a good example of what you're talking about there. We are not sort of encouraging anyone in any direction as far as development of front ends, so I don't think we're the right people to talk to about partners there, but VDI out there is a great example of someone who is creating those front ends.
Just like as kind of a follow-up, so I think in this millimeter wave space, there's, you know, kind of two things that millimeter wave buys us, right? There is this opportunity to go to like much wider bandwidths, but then there's also these this high directionality and beamforming gains and all of these algorithms. And I think from, you know, the algorithm people that I've talked to, you know, the bandwidth isn't actually that important to them. So I think if I think of like the NI platforms that are available that I've seen, I think your 128 massive MIMO system is actually cheaper than your like single element millimeter wave system, or like roughly of the same order. And so if you could put out a cheap millimeter wave front end that could kind of plug into that massive MIMO system and says, give you 128 elements, but we only have 20 meg of, you know, LTE style channel bandwidth, that would be something I think a lot of customers would actually be really interested in. When we were first starting Hardra and talking to NI, that was actually the biggest problem, was they were kind of pushing, you know, this 2 gig of bandwidth platform. It's like, well, we want data at every antenna, so obviously we can't buy 128 of these, you know, $1 million systems. So I'm just curious if you guys are interested in that space as well, if you're going into that market.
I think it's a great idea, and it's definitely been tossed around. We've had conversations with other customers around the same thing, and knowing that there should be an option with lower bandwidth. Right now, the platform doesn't support it, and I think from a historic perspective, to not get too much into the history, our components and our front ends are more designed for a test type of customer and a test environment where they have to be a little bit more precise. And so cost there, I mean, it just is what it is from a component perspective. I think you guys figured that out too, that it's hard to lower the cost of components there. So yeah, I think it's definitely something that we would explore. When is the right time and how to do it, I think is still up in the air, but for sure.
lower bandwidths, you can only go to a certain point before you can create a bigger headache for yourself. So 20 megs on a 30 gigahertz, you're inviting disaster because things are going to go, because you won't be able to digital process fast enough, and the variations are probably going to kill you. So, temporal variations, everything is faster at that. So you don't want to go too low.
I think it depends. It depends on your algorithm. If you're talking about like an OFDM-based kind of algorithm on that, your subcarrier bandwidth is probably below 20 meg in like a millimeter wave architecture.
That's right, but you're sampling faster.
Yeah, but I mean, in OFDM, you just have a smaller number of subcarriers at that point.
Yeah, actually, I also want to add a little bit from cross-layer design point of view. So, because I work on these networking protocols, and from higher layer point of view, right? So when we do the experiment, all we want to have this abstracted view. So basically, we want to change some parameters, physical layer, for example, and the beam pattern, or number of beams, and the power, very flexibly, so then we can do this cross-layer optimization, right? So it's really good to have a standard interface and provide the tool for the higher layer researchers, to control it. So.
Actually, that's a great point. So let me ask both, NI's platform, how much networking protocols can you play with? And then, Greg, where are you guys with your networking backend?
So I think, like the rest of NI's platform, it's up to the user and how much you want to put into it. We do have hooks in some of our products now to add in some network simulators like NS3, and use a more standard physical layer and then have a hook into a simulated network layer. But if you wanted to build your own network layer, that's something that you could do. Right now, those layers aren't available in any standard products from NI, but I think you should add it.
Yeah. So as far as where we're at on kind of the Berkeley platform, like I mentioned earlier, right now we're kind of unidirectional. So that kind of precludes a lot of network stuff, right? So we have our architecture is a closed loop beamforming. So the handsets send pilots, and then those that are scheduled with just kind of a reference clock, and then they send their payloads. And so we're just kind of lower end max stuff. Once we get the downlink into place, I think we're actually very excited about adding in hooks to do the network level stuff. That's actually something we're trying to prefetch a bit, in that we are. We have a couple students that are just kind of building on FPGAs more standard interfaces for 802.11 LTE and like a couple things like that, so that we'll have some example platforms about how we should plug in at the different levels, and we can kind of substitute our own hardware at the lower levels once we get to there. But it'll be a little bit before we actually have the downlink direction, and you're not going to do networking without downlink.
Yeah, that's true, but you could, okay, so you're developing FPGA based. So is that something you want to do, do you have enough, or is that something where a collaborative, like say someone, maybe Hank's group, or I know that there are some other folks who are more focused on the networking side, and they may be using a really primitive file layer, like some velocity thing from Qualcomm, which they are ready to pull their head, hit them, whatever. So they may be willing to reduce the time frame. Is there possibilities for teams working together in that regard?
That would actually be great. Yeah. Certainly at kind of the L2, L3 interface, where you're just kind of expecting like packets and scheduling, we don't have any secret sauce in that space. So somebody having a kind of structure and a standard interface definition that we can kind of put on an FPGA and just fill up a buffer and take info from that, that would be a great resource for us to have to kind of pair with people. At the L1, L2 interface, we do have kind of these closed loop beamforming algorithms. So our particular hardware that we're building is a bit more specific about what we would want. But I think we could certainly at least talk about, people being interested in getting involved in that and, how we could, if not standardize it, at least generalize it a bit more. Yeah.
Yeah, and I think that's what I think from a cross-layer interaction perspective, maybe if we could build modules which were on a common, we decide on whatever FPGAs we're going to use on a common platform, and then have some underlying common framework, and then some people could develop the networking protocols, and then they could be tested out on a particular hardware space, and then if we twist the right arms, we might be able to get, replicate it at other places at maybe a little lower cost. So some people, for example, I think we could provide front-end beamforming architectures at less, lens array-based ones, which are much less costly, and which could be an alternative to a price point and functionality to explore in a bigger context. Okay.
So just to, this is a great conversation piece. So just to distill it for what's the work or what needs to be done to get to that point is to sort of identify the players who are sort of developing the hardware, and then what I'm trying to understand is what's missing.
I think people getting on the same page about who the players are going to be, how you're going to team up, where to actually draw the interface lines, that's really important, obviously. Coming up with the right CAD flow as far as this FPGA stuff is really important. If you're going to actually put both layers on the same FPGA, you kind of have to be in sync about how you're going to implement it on there. Right now, I actually kind of want to change our flow, but I don't want to burn up the infrastructure I already have. So that's something we would kind of need to get on the same page about. And just kind of coming together and figuring out who's interested in doing it.
Yeah, I think in terms of the interface, right? So one thing is what parameter can be controlled. Another one is the measurement, right? So certainly the physical layer measure a lot of stuff, right? This CSI or each antenna was to receive the signal, and how much information or how much measurement can be exposed to the higher layer and can be used to design this cross-layer optimization. That's another aspect, Certainly there are a lot of trade-off, if you put a lot of measurement out, there's a burden for the hardware, but on the other hand, from testbed point of view, and you may give a higher layer designer some more controls.
So to use that as a sort of, I guess, jumping off point for what this particular Cosmos platform that was briefly mentioned, just to sort of give you an idea of what exactly the vision here is. Some of you have heard this, some of you might not have, but as part of that power program, this is one of the platforms that has been awarded, and the award was made in April of this year, so this team has just literally gotten off the ground with respect to their designs, etc. The teams are sort of listed up there. Majority of the players are actually present here at this meeting, NYU, Columbia, as well as Rutgers. So what's the millimeter wave side of the story? So before I get into that, essentially what the whole vision of this platform is to develop a multi-layered computing system with RF clients, flexible signal processing, network compute application. So it's sort of envisioned as an end-to-end system. Millimeter wave is obviously the key RF technology, but as you can see, this is pretty much envisioned end-to-end with a goal of actually being able to play at any layer of the stack that you'd want to play in. And you can sort of have a tunnel vision and focus on a particular piece without caring about what happens at higher layers, because that sort of comes as part of the baseline for these platforms. This is envisioned to be deployed outdoors around the Columbia University campus in West Manhattan. So this is around where the Columbia University campus is, and the two big parallel lines are Broadway and Amsterdam Avenue. It might be hard to point out here, but there are essentially large number of rooftop sites which will have multiple SDRs in temperature-controlled boxes or co-located indoors with wideband, multi-band antennas on the front end. So programmability and flexibility being a key design criteria for developing these platforms. The scale is about 1 square mile is the deployment area, with about 20 to 30 site locations on streetlight assets, 9 or 10 of those on rooftops, as well as a large number of small mobile, semi-mobile nodes that can be placed in cars, carried in backpacks, etc. And on top of that, all of these nodes sort of are connected via a fully configurable, reconfigurable optical DWM-based backbone. So ROADM switches will be deployed at each of the boxes you see. So wherever there's a radio site, it'll have direct connectivity via fiber to these ROADM reconfigurable optical switches that allow you to switch at the light level, which allows you to develop or create different topologies on the network side of things. So now you have a very thin RF client, large amounts of network, and then you have lots of different kinds of compute, again, co-located to the radio. So CPUs, GPUs, FPGAs, very close to the RF. So you could implement, or you could think about cloud RAN, radio over fiber sort of applications that can be envisioned. And this is, again, I'm right now focusing on the sub-6 space, so that's also part of the mandate. So as you can clearly see, I don't want anybody to have any illusion that this is solely dedicated, focused on developing millimeter wave technologies. It is envisioned to be end-to-end. There are large, lots of expertise in different areas that comes together to actually build this beast. So that's sort of, that's the overall vision. That's what's being done. They have about 5 years worth of funding. And as Akbar correctly pointed out, it is an infrastructure project. That's how it should be viewed. A lot of the research that's been brought or has gotten us to this point is obviously accelerated what this infrastructure can do or can provide to the community. But again, no illusions. This is pretty much about building and deploying this infrastructure at a large enough scale that allows research and industry as well as our SME startup folks to actually get access to things at scale, which would be very hard to do on a per company, per institution basis. So that was sort of the philosophy rolled into what Cosmos is going to do. With respect to millimeter waves, so essentially, the way we drew the line here, I think they will be focused on what we would like to call, at least in this room, the 5G spectrum, so which would include 28 gigahertz to begin with, and then the ability to scale up to 60 gigahertz. And that's what the plan is. Again, as I said, April 9, 2018 was when the award was made. The millimeter wave development roadmap story is still evolving, and that's sort of one of the reasons, at least I'm here, to keep my ear to the ground, understand from this community what exactly is going to be beneficial to the community, because this is sort of an avenue that's been presented or provided by the NSF, and we want to understand that we're not building something that nobody's going to use in a year and a half when this will be available. So getting your input here is absolutely paramount for us as we think through these things. So for the 28 gigahertz, what essentially we have as part of the team is a IBM team which is going to provide the 28 gigahertz phased array. I can give a little bit more detail if people aren't already aware of this. This was sort of a well-cited, well-published paper by an IBM Ericsson team. So 64 antenna elements, essentially 4 ICs, multiple TX-RX pairs, and essentially it outputs out 3.5 gigahertz IF, at which point you need some or some large amounts of baseband processing if you're doing what the Cosmos team eventually wants to do, which is 8 simultaneous beams, 500 megahertz or 800 megahertz of bandwidth. But to begin with, the plan is obviously to start small, which is with a single stream. We are trying to work with NI to sort of understand what are the best ways to actually get that baseband processing done so that these systems can be deployed. And that's sort of, again, one of the avenues that we want to understand. And this is where it becomes semi-attractive to move along that thread of a modular sort of a setup where you can sort of plug and play different configurations. Hey, you bring this expertise, you do this, you define the interface, and you sort of plug it in. I think that's sort of the same design philosophy the Cosmos team has with the IBM team, folks from NI, as well as the NYU and Columbia team providing some. So with respect to where millimeter wave will be deployed, I think the goal is within the first year and a half to have about 25% of these sites be millimeter wave capable, having that phased array RF front end, which will be available to the experimenters. And at this point, sort of, I reflect back and we'd like to really understand what are the kinds of things. So if you put on your best fortune teller hat and think ahead to a year and a half out, what sort of research challenges would you envision this community struggling with or wanting to implement, validate, publish, etc.? Because that is obviously one of the key mandates of these platforms as well. So, any feedback to me, and I'll relay this back to the development team. If you see Sandeep, Harish walking in the hallways, make sure you tap them on the shoulder, let them know. But the timeline, at least for this community, is with respect to something that's going to be available for you to play with very early on in a sandbox environment by October, November this year, with a small set of outdoor deployed, remotely accessible community testbed a year and a half from now. So, pause here, take questions.
I have a question. So did you say an IBM 16 4
Element, yeah.
4 antenna elements? So 64 element array, but each patch is 4 antenna?
That's right.
So a single beam would only be formed with 4, or would it be formed with 16 elements?
16.
So this is 16, I see. So 16 element, 4 antennas.
That's right.
Okay. All right. So 16 by 64. Okay. So this is going to be, so this is great, and I think we will give a pointer for, tomorrow or two to give feedback. But, this is a single beam, so this is, for millimeter wave, this will be small steps, I think, in some ways. And I think this would be a great where we can get in and plug in. That would be really useful. That would be nice interplay. But what we want is, so Hydra is multi-channels. We can do multi-channels and other places too. What can we do in parallel for community testbed development, which could eventually, we could try some new algorithms, and then they could be really tested on the power platform. So I think that's what we'd like to get here as well, but this is really good input. Thanks.
Yeah, it's one piece of input I kind of have about just this array architecture is it's really nice if you can find a way to get per antenna channel state information recorded somehow for experimentation. Because I think, even if we look at platforms that we want to build and we say, we're not going to put a data converter at every antenna, as like a low-level circuit designer, maybe we can put some kind of interesting, innovative blocks there to kind of cooperate at like the per antenna level and the higher level. So having that capability so you can test these algorithms out either digitally or in software or something like that is like a nice capability to have.
That's great.
But that's actually a good question, and I don't know if they can necessarily.
Yeah.
I think this is probably a 16-element phase array with a code book or something, and they may not even be measuring it.
Right.
So it's going to be millimeter wave in a straitjacket.
Yeah.
So I guess contrary to that, I think now is the time to bring those up when we're still, and I don't know why I said we, while the teams are still interfacing with someone like IBM to actually push them for that information and to make that available. I think now's the time to hear that.
Yeah, and then that's exactly right. So that's the kind of feedback we want to hear while.
No, I agree, but I'm just saying that.
Yeah.
I think their
feasible
hardware is not capable of providing that information.
No, understandable, but that's what we want to see. What if this is useful and at what level would it be? So I think thinking of at least these platforms down the road, I think the model that you suggested here, where you're leveraging other test beds, maybe your sandboxes, and actually getting yourself ready for these systems to come online, so that you can actually port over or bring your experiments or bring your research to actually conduct on these platforms would be really good. And that's sort of that pipeline that we want to start filling today, so that we are ready.
So I think having said that, I think the point that I think Power should be, and I would think would be doing, is to actually record all the measurements as much as possible, especially in the millimeter wave space, and store it in a format that's easily accessible. And point out and put these questions so that they can say, sorry, we don't have this, but we can provide this. So anything and everything from physical layer and beyond that can be recorded and kept is useful.
Yeah, and I think that's exactly the point, is we need to be making it so that, in 3 years, the testbed's still going to be somewhat in its infancy, when new arrays and new hardware is going to be very much available and very much mainstream, where if we put in the hooks for the information that we would want to have that we might not have available right now, then it's going to be a lot easier to go up onto the roof and just switch out the array.
Yep.
And make changes much easier, and then also have some parity with data. Even if it's not there, we still have the same format and everything like that. So so experiments are much easier.
Right. So the measurement philosophy, I think, has been imbibed by the team, and I think while we're talking about these platforms being deployed, the first sort of set of experiments, quote unquote, that the platforms plan on running is a measurement of the environment that they're in, and actually providing that. So a sample experimental workflow would essentially entail a user or an experimenter getting, either in simulation or models, and validating, quote unquote, your experiment on a simulation environment before actually going out and doing things in the wild, as any of you who's even tried anything to do outdoors could attest to. So that's sort of the first thing, that the measurement, what some of the formats are. I think I personally, again, am not aware of standards that sort of do exist. There is a SIG-MF for capturing the measurements. So are you talking about just developing? Yeah. So I'm talking about capturing base IQ samples essentially. And are there easy ways, standard ways of capturing, storing metadata, artifacts?
What these guys were supposed to figure out.
Right.
And they have been funded now, so they better know the answers.
There we go. See, they conveniently ran out of the room.
They better, so this
okay, let's just add work onto them. That's what happens when you leave the room, right?
No, I'm not joking. I mean, I was in the back end of multiple teams, and this was part of, they should be part of the plan, that, hey, what is the best way that we store this information? And I'm sure that there are formats, and I can't remember, but there are formats which can be used for storing this large amounts of data.
So that was discussed at one of our very early user workshops, not for Cosmos, but for the other platform, and I'm sure that's semi applicable to this as well. But yeah.
So I actually had another kind of follow-up question about kind of the capabilities of the system. You'd mentioned, initially you guys are planning on looking at, 28 and 60 specifically. Kind of like, say you want to do 28 versus 60, what does it look like to actually like change out those front ends? And, is it going to be modular such that, 3 years from now we say we want to do 140, what does that look like to change over to that?
Oh, absolutely. Extensibility, modularity, like the way the base RF design of the unit is intended to be, it is intended to be a swap in, swap out system.
But so I guess, where do you draw that interface line of the swap? Is that like essentially data converter samples? Like, is it IF?
IF.
Okay.
Yeah.
Okay.
IF. That's again today's thinking. And again, I don't want to speak for the team, but that's the latest information, at least I have from them.
I was going to actually bring us back to the question of if power would include over 100 gigahertz and what that would mean. From my standpoint, I think that the power testbeds actually give us a really great opportunity to be pushing the boundaries and pushing the limits of what the FCC will allow us to do with experimental licenses, and then having a somewhat secluded area that is still public that you can start deploying and start testing that you wouldn't have elsewhere. You wouldn't have a city that would, where you have a very close relationship with FCC to actually start deploying and start working out some of the issues of coexistence. That would be where I would think in 5 years, I would hope that this would go, is being able to swap that in. Go for it. Nope.
So since you brought up the little issue of what FCC will permit, the real, especially if you talk, when you go above 100 gigahertz, I wanted to give a preview to my poster, the real reality is that NASA is a pain in the neck. NASA essentially has veto power over NTIA, and NTIA has veto power over FCC. And I would go tell NSF that NSF has a seat at the table along with NASA. And as far as I can tell, there's no sign that NSF is trying to moderate NASA's extreme protectionist goals in its seat at the table. And that, because in reality, if you want to do experiments, say above 150 gigahertz, you can't walk into Radio Shack and say, I want 170 gigahertz transmitter. You know, you have to take what transmitters you can get. Otherwise, you spend $5 million commissioning a transmitter. That's the reality today that makes above 100 gigahertz very different than say 50 gigahertz. And there needs to be some pragmatic attention at NSF management to stop this harassment of R&D people by NASA, who are not interested in protecting their satellites. They're interested in forbidding uses of spectrum, any use of spectrum their satellite uses, rather than discussing whether the experiment threatens their satellite. I mean, I have a client in the university that was kicked out of 2 bands by NASA, and they were bands used by non-geostationary satellites, and it took a couple weeks of extreme effort to convince NASA satellites that are on the other side of the world do not get interference. NSF was on the committee that decided that. There's no sign that NSF was aware or took any action to moderate when NASA said 24/7 you can't use that band ever, when there was only one satellite to get it. This is a real problem above 100, 150 gigahertz, and NSF should try to get NASA and NTIA to focus on protecting systems, not forbidding any use of certain bands.
So, right. So again, none of us are from the NSF, and Akbar stepped out of the room. But what I can tell you is from interactions with the FCC, and just to build on Kira's point, the way this program experimental license has been conceived, this allows for experimentation. Okay. Well, we'll learn. We'll find out.
You listen to what you wanted to hear. But I can give you license application after license application.
That's been rejected.
Sure. And particularly program licenses exclude, the rules exclude band subjects to the US 246 provisions, which are these passive bands. So go read program license rules. Sure.
Well, we didn't encounter the 100 gigahertz and above because that's not in the purview. You're right.
Above 100 gigahertz, the program license rules specifically exclude using those bands.
Okay.
And if you go get a regular license, you get the problem for a different reason.
Got it.
So nobody wants to address.
Yeah.
But
well, say that again when I guess Akbar comes here, because this constituency here can't really help you.
You could report.
Oh, he's back.
You should be, presumably you're reporting to him.
Right.
And the issue is above 150 gigahertz, there are spectrum access problems anywhere in the USA, and NSF has to engage that.
Okay.
So my hope, and this is also, again, a naive hope, is that we can start using platforms like Power once they are off the ground to start addressing some of those and getting some backing and getting some voice behind it that we might not have had in the past. And that's, again, a very naive approach to it, but that is the hope, is that we'll be able to at least get some more eyes on it it's been a highly publicized program, so hopefully we can get some more power behind it. Again, naive, I know, but.
I actually have kind of another question about kind of the FCC issues, and if you guys are going to look into this for power. Is I know Facebook faced this with the Telegraph system. Is that even though it's really a point-to-point system, because they serve multiple users via time division multiplexing, the FCC called it a multi-point system, and that reduces your EIRP limit by 40 dB.
Right.
So there's this question of, what is a limit due to safety, and obviously we need to respect those, and what is a limit due to, they're just not actually interpreting the system correctly. So do you guys have a sense of what EIRP you guys are actually going to try and push out of power?
This is trial by fire. So essentially, we get a step ahead of the program experimental licenses. So basically, what you see in the deployment area will be classified as an innovation zone, and essentially that relaxes some of the requirements that you have on the current ELS, experimental licensing systems, etc. So there's more leeway, and that's all I can say for now. Again, it's going to be trial by fire when we actually deploy these systems and we encounter these issues, but we obviously want to monitor them. You brought up Telegraph. I just want to at least bring out in front of this community, and you can just nod if you're already aware of this, but the 60 gigahertz Telegraph radios, Facebook wants to give those out to universities for channel sounding and for channel modeling efforts at a very low cost with limited support, et cetera, et cetera. Is that of interest to this community for 60 gigahertz channel modeling? Is that already, you already know how to do that? Do we have enough model information data? Because
Potentially, but it remains to be seen what they can do if it's single beam and what's the characteristics, but that could be useful, and I think, and I want to, we have 15 minutes, and I want to get a little structure on, suppose we were to say a community project where we wanted to have multiple teams carve out different parts of a project to develop a test bed, which could be complementary to power, feed into that, but maybe even if power didn't exist, how would we partition it? So one would be, it's like a natural partition would be, some people could be doing the antennas and RF hardware, some teams, or it could be partitioned one, potentially I'm thinking FPGAs and A to D could probably be one component, the hardware, and then maybe the networking folks could be another one. There are three teams. But then, in terms of other players, you mentioned, some technician at a company. What are the different components that we'll need to bring in, say, in a 3-year time frame? So one of the goals that I want to put forward for, I'll put forward tomorrow, is that we have 2 more meetings of this RCN and the original thing, which is about a year from now. And so what can we develop? Can we develop a plan in terms of what we need, what we do, what will be the teams, what are the players we need to put in, and what resources we need to pull that off, which could go in parallel. Cosmos is the only one right now with millimeter wave, but that's not the focus. Maybe there'll be another platform focused on millimeter wave and terahertz, who knows? So what can we do going in parallel, and how would we break it up?
I guess one, I think, set of researchers that have been missing from this is packaging researchers. When we talk about hardware, I think the circuit design community is pretty well represented at these events. But so I know Georgia Tech does a fair amount of research in millimeter wave packaging. There are a couple other schools, and I think getting representation from that community, people that actually know how to do high density interconnects with that operate at 100 gigahertz. Would be a community we really want present. And that would be a big piece to kind of doing a collaborative project.
And I think this is a part of Cosmos too, that right now what's happening is just like Telegraph, Facebook is giving these 60 gigahertz radios, but now companies are also beginning to provide, even analog devices has these evaluation kits or TI and so on. And so they are interested in it. And so one, are there any, I think Thiago was mentioning that, Maybe ADI was going to provide some of the baseband architecture for Cosmos. Are there partnerships like that possible? And other than packaging, are they? What about who would build it? Even we have researchers, but at some point at the end, you have to, ask someone to build the RF hardware, put it on a board. Right, so
but that's
the easy part, I guess.
But that's actually, I would say, that's the hard part, because that's, you're now, if you're trying to go to, and that's, we faced this in previous projects, you're competing with the Apple, Samsungs of the world when you're trying to go.
No. You don't want to commercialize.
No, but even to build on, you're not talking, you're going beyond just dev boards, etc., right?
It could be like a dev board. You take there are these three different wafer scale and then these surface mount components, and you could create an RF layout. We had a discussion a year ago, and then you could have some third-party company put those components onto a board. That's what he was referring to, wire bonding stuff. So do you want to have?
Well, so I think who the good companies are to collaborate with this is kind of up to what architectures you want to explore, and that so I think people have a pretty kind of, like you said, millimeter wave straitjacket about what 5G is going to look like. It's going to be hybrid beamforming. You're going to have partially connected arrays where it's really one beam per subarray and things like that. And so if you want to keep going down that road, then I think we can talk to Facebook about this stuff, and other people like that. They actually have pretty well integrated modules, but you're going to be straitjacketed to that architecture. If you want to talk about exploring new architectures where you do fully connected arrays and other things like that, you kind of have to get more to the principal components. And as far as that point, I think at 28 gig, I haven't done that much, but I think there might be some kind of principal component players. At 75 gig, which is where we've done all of the Hydra stuff, it's basically ADI, and that's it. And so, yeah, I mean, they've been very helpful for us, and they are actually, I think, interested in collaborating with academia. But I don't know how far they'll go as far as trying to build up a larger scale eval board than what they already have.
So this is I'm trying to sort of, we're getting to the end of the time, et cetera, but some action items, some, distill down what we sort of went through in the last hour and a half. So I think this approach of, at least, Akbar, what you suggested about what is it that this community can do together, who the players are, sort of identifying. So this is sort of a fact-finding mission, I guess, where we need to put on paper who the players are, what expertise do they bring, and what are sort of a gap analysis of which are the pieces that are missing, engage our industrial partners, engage companies, sort of make those connections that we have from the expertise in this room, and sort of scope out what this would look like. That would sort of be one challenge, and sort of understanding where that falls into the roadmap of large-scale systems, plus what people are doing in their labs already with Hydra, with NYU Wireless, with other universities that are part of this consortia RCN, and then sort of presenting that roadmap to the community and sort of understanding, here is where we want to play, here is where we don't see either an industry player or a company doesn't really see the value because it's not part of their business model, it's not addressing a large enough community or customer need, but it's still important enough stepping stone for this community to get to the point where it gets interesting for other industry players. And I think that's sort of, I would take that as sort of the next steps to do as we spend the time. And you said you have, a year and a half, and a lot changes in that time. Breakthroughs happen. So just to be cognizant of, what will be, what's going to be feasible and possible, and sort of being very realistic of, if the suggestion is to do something in 2020, where will industry already have been leaps and bounds and, gotten how far, and where actually realistically we'll be able to build anything. Just want to put that out there. We should be cognizant of that too.
Oh no, I think I have no illusions about that, but I think industry will go in their specific directions, where their vision is governed by 3 months. So academics have a possibility here to kind of think a little longer and also take on some of the hard work to build it themselves, because we can't just wait for industry. With all due respect to industry,
Sure.
something we have to do ourselves too.
Akbar, can I just turn around another question for you on this kind of, if we were going to try and build something like this, what's the budget, right? Because, yeah, like,
Hey, money is known to fall from the sky, especially in Washington, D.C. So no, listen, the point here is we don't have a budget. No, I want, what we are looking for is, hey, what is it, are people interested? Is the community interested? Who are the teams? What is the blueprint? And what resources are needed? What would it cost? You come up with that, and we'll do our best to make it happen.
yeah, well, I guess I just wanted to figure out how that fits into, NI does have a lot of platforms available, right?
Yeah.
And I think they are kind of expensive for us, right?
But but we cannot do everything with NIs. With all due respect to NI, there's also a LabVIEW straitjacket on it, and other straitjackets. So and they don't have a networking part. So we want to be able, and we can bring in NI, people who are LabVIEW enthusiasts can go in there. We can bring, MathWorks stuff to processing, to whatever we want, but I think it's an end-to-end system where we can play with it, modular at every level. Is it possible? Is it feasible? Are we interested? Is the community interested and committed to doing it? And what would it take? You create your blueprint, you create your what is needed and what resources would be needed, and then it's our job to try to make it happen in terms of providing the resources.
Yeah, actually, to follow up this, right? So where we have this, what do you call that? Power phase 2. So I think I don't know the status right now. I didn't follow recently. So initially decided to support 4 testbeds, right? So right now there was 2, and they're gonna have another call for proposals for the other 2. So
that's pretty much that. So that's round 2, which will fund again up to 2 more platforms. That will again follow that same RFP model that NSF follows, and that is anticipated to release by Q3 of this year, with an award date of August 2019.
But let me just be clear that what I'm asking for is not in the purview of power.
It is not.
Power is about creating a large-scale testbed which is flexible, more infrastructure. And I think a single power platform dedicated to millimeter wave doesn't even make sense. Not right now, maybe it might make sense, depending, So this is a separate thing. This would be an effort where we build, that effort will produce components which could go into any and all of the power platforms, Cosmos, Powder, wherever they have, because that is what they ought to be able to do. If there's any power platform that cannot support emerging millimeter wave technology, then we haven't done the job.
I was just going to make a closing thought that it is interesting, at least in this discussion, which it is a small group here, so it might not be representative of the rest of the community, but we did focus a lot on very low level and componentized discussions rather than applications that could be enabled by a testbed, which I think is a very interesting space and maybe is reflective of where we are in the community. But is something to I guess keep in mind as we do look at other MRIs, CRIs, and power that we might be a step before really application-based needs. That's a good point, that we may have self-selected into a group of just talking about that. So that's a very good point.
We have made tremendous advances, but again, it's not the end of. It's not just an engineering challenge left. There are a lot of things which are not solved, and millimeter wave and higher frequencies will have similar challenges. So I think these kind of testbeds and thinking about them could be very interesting. And it is complementary to what power can do. I think there's a lot of misconception, not a lot, but misconception what power is about and
Absolutely.
what other things are.
Right. So the one thing I think, again, we can wrap up any time here, but just thinking about what's the for the partners that you mentioned, these are, what's the value proposition? What's the, why would they come to the table for an initiative or a program or to set up a blueprint for? The one thing again on the, just in telecom, mobile communications world, this whole notion of open API, open interfaces, openness has sort of, taken forward. So I think if we jump on that, if we piggyback on that sort of stream and frame this conversation around this openness aspect, I think we're, much more likely to get some traction. So to move it out of just the technical domain, I think, we have to put our own hats on what is that partner going to bring or what are they going to benefit out of this flexible millimeter wave platform on their end. Because at the end of the day, if they don't see any value for them, it's going to be hard to get them to the table. I just, again, things to consider, not, and we felt that with, power as well.
Well, I agree. I think that, but I feel that, if enough, so we are looking for people who are interested in solving the technical problems. Okay, and I think the community has enough bandwidth to collectively solve these problems.
Yep.
And we have enough resources so that we can tap them to do the things that we cannot do, like, wire bonding that easily or whatever.
Yeah.
And I think we can do this even without having big players come to the trough, so to speak. That's what I feel. And I think there are examples. Hydra is one example. What, we were able to do is one example, and other players too. So I think this is possible. It's really up to the community how much are they really interested in making that happen. And the value proposition is going to be the greatest for the community itself, and then, it might open the eyes of the industry too.
Yep. Okay. Yeah, no problem. Thank you again for those who participated, and obviously we'll gather on our notes, our thoughts, and present this when we do a breakout then. Thank you.
Thank you very much, Manu. Thank you for everyone. And yeah, we will have a readout tomorrow. And this is, it's a very important readout because the rest of the groups missed out on very important discussion.
Right. Thank you, guys. Thank you for participating.
They missed.